Today we're talking about rate of change, which is related to slope, which we talked about yesterday. There's a couple of main differences between slope and rate of change. First one is that rate of change usually has a practical application to a situation, such as in miles per hour, or feet per second, or dollars per minute. The other difference is that rate of change can be calculated over a small portion of a graph rather than a whole line. So for a whole line, the slope is one amount that doesn't change. In other graphs, the rate of change can change depending on where you are in the graph. So we're still going to use it to calculate it the same way. We just might have different rates of change over different areas of the graph. So in example 5, we're given some information. Told that we are given a table that shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. So for 2 hours it costs $7, for 4 hours $14, and for 6 hours $21. So we're going to calculate it the same way. We're going to take the difference between two outputs, and I'm going to choose the two outside ones, 21 minus 7. And so if I do that, then with my change in inputs, I take the same inputs that go with those outputs. So since I had 21 as my first output, I'm going to choose 6 as my first input and 2 as my second. Now it's important to remember that this was measured in hours and this was measured in dollars, because that's going to come into play here in a second. So when we simplify, 21 minus 7 is 14, 6 minus 2 is 4. When we divide, we get 350. And since our output was in dollars and our input was in hours, then we have $3.50 per hour. And so in this situation, what that rate of change represents is the cost per hour of use for the computer in the internet cafe. Every 1 hour costs you $3.50. So rate of change allows us to break it down to a per unit change, per hour, per minute, per mile. Okay. In example 6, we have a picture. We have a graph that we want to find different rates of change on. So we'll put that up here, and we'll use that to pull some points that will allow us to calculate our rate of change. So here's our graph. The question says a community theater performed a play each Saturday evening for 10 consecutive weeks. So you notice that on the graph, the input is measured in weeks. So each of the input values tells us what week it is. So here's our first week, second week, third week, and so on. And the graph shows the attendance for the performances. So here's our attendance along the outputs. Okay. And it only gives us the exact information for weeks 1, 4, 6, and 10. Now, you might be missing a little bit over there. If you can't quite tell, that point is 1072. Describe the rates of change in attendance with respect to time. So if you notice, this graph has different slopes in different areas, and so that means the rate of change is going to be different for different areas. And so we're going to calculate the rate of change for the 3 different sections, from week 4 to week 1, from week 6 to week 4, and from week 10 down to week 6. So all we do is we use these as the input differences for our slopes, and we put in the associated outputs. So in week 4, there were 232 people. And in week 1, there were 124. And so when we simplify that, we get 108 over 3, which is equal to 36. For week 6, we had 204. For week 4, we had 232. So when we simplify that, 204 minus 232 is negative 28. Divided by 2 gives us negative 14. For week 10, we had 72. Week 1, we had 204. When we subtract, we get negative 132 divided by 4 gives us negative 33. Now, since the output is measured in people and the input is measured in weeks, then for weeks 1 to 4, we have a rate of change of 36 people per week. And since it's positive, that means the attendance went up, which we can clearly see on the graph. For weeks 4 to 6, we have a rate of change of negative 14 people per week. And since it's negative, the attendance went down, which we can clearly see here on the graph. And for weeks 6 to 10, our rate of change was negative 33 people per week. So we have a negative rate of change. The attendance went down, and as you can see, it went down steeper than the previous interval. So there's our rates of change calculated by looking at the graph. Let's look at example 6. A student commutes from home to school by walking and by riding a bus. Describe the student's commute in words. So they give us a graph and they want us to postulate what might be happening based on the picture. So let's put the picture up on the screen. Now, the output is distance, the input is time. So this graph is telling us how her distance changes over time. And so what we see in this region here is that her distance is increasing over time, but not very quickly. So since her distance is increasing at a slow rate, that is probably where she is walking to the bus stop. The next interval, her distance is not changing, not going up or down. She's not getting closer or further away. So if she walked to the bus stop, why would she not be moving after she walked to the bus stop? Probably because she is waiting for the bus. Then we see that her distance changes a lot more drastically over the last interval. Her distance changes really quickly. And so we can assume that this is where she is riding the bus, which is the logical outcome after she's walked to the bus stop and waited for the bus. And so that's our scenario. That's the whole lesson for today. You're using graphs to calculate a rate of change or interpreting the rate of change from the graph. So if you have any questions, feel free to ask. If not, you can move on to the homework.